Okey, Assalamualaikum dan selamat petang. Okey, kita mulakan majlis kita hari ini dengan ilmu kita Al-Fatihah. Okey, Alhamdulillah. Kita bersyukur pada Allah. Lepas kita dapat berkumpul hari ini, insyaAllah dengan berkongsi ilmu dengan tajuk kita pada hari ini, presentation daripada Dr. Shaiful dengan tajuk Computer Network 1.1 The Critical Enabler for Internet of Things, IoT, Industry 4.0 and Society 5.0. Okey, lebih dulu saya akan perkenalkan Dr. Shaiful. Siapa ni Shaiful? Okey, Dr. Shaiful ialah is currently Associate Professor in the Department of Computer and Communication System Engineering, Faculty of Engineering, UPM. He received his PhD from Cardiff University, UK 2011. MSc from National University of Malaysia 2003 and Bachelor Engineering from University of Birmingham, UK 1998 in the field of electronic engineering. He is one of the winners of the prestigious IEEE NTT-11 2008 Creativity and Organicity of Microwave Measurements competition. His research interests are cloud computing, Internet of Things, IoT, network security, and non-linear wireless measurement system. It has contributed to more than 100 technical and research publications. Okey, tanpa membingungkan masa, saya menjemput Dr. Shaiful dengan presentationnya seperti dipaparkan pada slide. Dijemput Dr. Shaiful.
Alright, terima kasih. Thanks for Mr. Hisham Ali for the introduction. Alright, thank you for attending this seminar despite your busy schedule. Alright, and thank you for the department for the arrangement and and inviting me as one of the speaker in the seminar series. Alright, I think everybody can I hope everybody can see the slide. Hopefully I can share this slide later on. So basically the presentation today is about computer networking, crucial enabler for Internet of Things, Industry 4.0 and Society 5.0. Alright, okay. As we see, the contents is listed. They're a bit long. Hopefully, we can finish within this 2 hours, right? And I think in the middle we're going to have some, actually one video presentation, and I think Mr. Hisham will provide the link. So we have a break about 50 minutes or 10 to 15 minutes in the middle. All right, and the content of today's presentation is that we're going to talk about IoT, Industry 4.0, Society 4.0, and My Digital. And then we're going to, actually this title or this topic a motivation for computer networking, why we need computer networking and the internet. And then we're going to go into the fundamental computer networking 101. The meaning is that computer networking principle or fundamental, right? 101 meaning the basic, okay, the basic or the fundamental. And then we're going to learn and probably explore the principle of the computer network and internet. And then we're going to see how they work and how they function together to perform a cohesive system. And then we're going to see the learning tools available, if we want to explore more on the subject. And then the conclusion, then I'll give you some further readings. All right. Okay. So what is IoT, Internet of Things? Because we have many, whatever terminology inside there, in IoT, Industry 4.0 and Society 5.0. So the first one is IoT. IoT is the meaning of IoT is Internet of Things. Basically, this describe network of physical objects or things that are embedded with sensors, software, and other technology for the purpose of connecting and exchanging data with other device and system over the internet. This is taken from the Wikipedia, but more or less the idea is that you have a connected things or stuff that you want to, you want to transfer data between the sensor and and the internet and the server and so on. So this is the idea of Internet of Things. All right, as you can see, this is the evolution of the Internet of Things. Okay, I'm not sure about you, but when I was young, I learned to to use the email, web browser, search. That's the basic connectivity, right, for using the network or the internet, right? And then we have this improvement of connectivity in terms of network economy. People start selling on the internet. You have this Amazon, for example, right now. Amazon is one of the biggest player, and they start with e-commerce and some other some other business, and then we start collaborate using email. I send you my document, and you can review the publication and so on by email. And then we have this immersive experience where we have a digitized interaction. For example, we have we play games over the internet. For example, like you play chess over the internet, right? So this is kind of immersive experience. You can play real time. And then now we have the pinnacles, whatever, in the state of the art, where they have this Internet of Things. So as you can see, the Internet of Things is not something new. It's just some evolution of the the network or the internet itself. Okay, and then is the idea of this Internet of Things, as we mentioned, is basically to connect the sensor and digitize the physical world or the real world information and kind of present it in the better form or more easier to understand form for people to consume, right? Because or this is or it can be consumed by other things as well. It doesn't have to be human, right? So this is the idea of this IoT. So it's basically the evolution of the internet and the computer network itself. All right, and as you can see, this is the comprehensive kind of IoT solution architecture. The reason they call it solution because in engineering normally we're dealing with problems. So when you propose a system, you call the system a solution. Basically, is a system, IoT system, right? Okay, and then as you can see here in the middle we have the edge, and then on the left-hand side you have the sensor actuator, and as you can see you have an internet gateway or data acquisition system, which involve data aggregation and measurement, analog to digital, and so on. Can be digital to analog as well, converter. And then on the right-hand side of the edge, you have these analytics. It can be at the edge or the server in your house, for example, right? That meaning at the edge, meaning that it's closer to you. Or you can be, the information and data can be processed in the data center, which is in the cloud, right? So this can be far, right? Maybe you heard like last week, I'm not sure, last month, Microsoft announced that they're going to provide or build a data center inside, inside Malaysia, right? Soon, sooner, maybe this year or early next year. So the data will be, even though it's in Malaysia, it's still very far from our house. It's kind of a bit far. So the edge is probably very close to your house or maybe inside your house. So that's the meaning of this edge, right? So as you can see here, a lot of equipment. And then the main idea is that you can have, if you see at the bottom, you have the data flow and then control flow. I think this is quite important because you have to understand, let's say if you want to get the data, then you can just get the sensor data. But let's say if you want to control, for example, you want to turn off your, if your light or your aircon connected to the internet, you can turn off your aircon when you away for whatever reason, right? So you forgot, maybe when you went out, you forgot to turn off your aircon, for example, because aircon is very expensive, right? The bill, and then you can not only you can see the temperature of the aircon, you can also turn off. So this is the flow at the bottom, and the next one is actually the simplification of the previous slide. So it's basically you have to understand that the flow information across these 4 stages of this IoT system and solution. Okay. Right, and obviously is that it's not only for control. Internet of Things or IoT is also used as as a data analytic platform. So basically, you use the IoT in conjunction with data analytic platform. So the idea is that you're going to process the data or the raw data. As you can see here, for example, this is the example that I give. You have red, which is the color of the traffic light. I think most of us, or every day we encounter this traffic light, right? So you have this, and then these two number can be your latitude and longitude, your GPS coordinate, and then the number is IP address, the node, the internet node, for example, and then what version software, whatever we're using, so V2. So this is the raw data in terms of, in this case, probably in terms of CSV, comma separated value is the raw data, right? And then this, can be turned into more meaningful information. For example, is it from the, from the traffic light in front of you, or the traffic light, nearby you? Basically, the other traffic light facing the another street, like Queen Street, whatever, right? So maybe this traffic light is turned right, and then there is a context here. So the traffic light, is it if the traffic light is exactly in front of you, so you have to pay attention. So you need to pay attention and do something. And then at the top of this data analytics, you say, okay, I'm going to stop the car. This is the kind of the top process. Okay, you think maybe this is nothing, right? But if you think that, if let's say you are designing autonomous a car or co-pilot system for the car, I think most of the modern car now, they have this automatic emergency braking, or they call it AEB. So this is how they work, basically, right? So if they're sensing something, or the object, or in this case a traffic light, right, they will going to stop when it's necessary to avoid accident. So as you can see here, we have this data, and then this information, and then you have a knowledge, and then it's turned into wisdom, which is the action applied to the context of of your activity. In this case, the car has to stop to provide safety against the accident. All right, and then this is another extension of IoT and data analytics. As you can see here, IoT in conjunction with data analysis and analytics is being used to provide a lot of analysis, right? So in this case, you have this descriptive analysis, diagnostic, predictive, and then prescriptive. So the highest level prescriptive analysis is similar to this wisdom that we discussed before. So yeah, basically this is the what you call it, the higher level action that you need to to decide, okay, based on the situation, right? And sometimes the decision can be many weeks, for example, right? If for COVID, if you send for analysis, the result can come many days or many weeks after that. Or in some of the cases, like in the automated car or autonomous car, or maybe you need to respond on time, within a fraction of a second. So yeah, if the time gets shorter, it's going to be more difficult to manage or to analyze. All right, so and then we come to Industry 4, or what they call it, Fourth Industrial Revolution, right? Yeah, basically this Fourth Industrial Revolution, or IR 4.0, they call it. Actually, this is more towards the industry, because as you know, industry playing a big part of the of the economy, and this is where people work and produce products, useful products, and so on. So this industry revolution, depending on computer networks, especially on the automation, and then this Industry 4.0 can be connected to internet, or can be they have the internal internet. But the idea that they have this large scale machine to machine that can communicate with each other, using the IoT, and they can be integrated to increase the automation and the communication, to analyze and diagnose issue with or without human intervention. All right. So this is the ladder or step ladder, as you can see here. When we have this Industry 1.0, this is the old mechanical kind of, in the old days. This is in the 18th century, and then we move to Industry 2.0 in 19th centuries, where you have a better, mass production assembly line, and probably in the beginning of electrical energy. This is better than Industry 1.0. For example, here you need to manually pull your pulley, whatever, right? And to lift a heavy lifting kind of thing. So you use a pulley, but in this Industry 2.0, you don't pull it. You use kind of steam engine or kind of automation, semi-automation to do that. And then the Industry 3.0, you have this kind of what you call it, complete automation, okay, and where robot do a lot of this stuff. I've been to Toyota, I think one of the Toyota factories in Japan, where they have this about 80% robot, maybe 20% human. So they do this, kind of nearly complete automation where they provide this. I think the very popular car here, I think we call it Velfire or Alphard. Right? So that's the only company or factory in the world that produce the Alphard in the world. So they are very highly automated and very high quality product, as you can see from their very popular Alphard and Velfire, van or vehicles or car. Right, and then you have the latest one. We have Industry 4.0. This is what I mentioned. It's kind of the cornerstone in our new industry, where you have this virtual and physical, function interface. All right, it's not only physical like we have inside the Industry 3.0. You have a virtual or software-enabled function where you connect this to the networks and to the Internet of Things. Okay, you have to understand that actually the Internet is not necessary here. It's optional, right? And then it can be inside the Internet network. Sometimes the company, they don't want to connect to the Internet because they have their own internal computer network, so it doesn't need to be Internet. But if you want, for example, now we have a COVID. Let's say you want to control the system over the Internet, you can enable it with, of course, security concern and security mechanism in place. So what the benefit of Industry 4.0 if we want to take this up, right? So this Industry 4.0, as you can see, give a lot of benefit. You have customization, instead of just mass production, right? I remember one of the very popular, very popular quote from the guru of this Ford, right? Ford vehicle, right? Henry Ford. You can have the what color you want, as long as the car color you want, as long as you have a black. The color is in black, right? So this is very popular quote, right? So they were doing Industry 2.0 or 3.0 maybe, right? So you cannot even change the color, but now you can even order the color of your car, depend on which color is supported, right? So maybe in the Industry 4.0 you don't need to order the color. You can just apply the color yourself, right? You can just click the button on your PC, and then suddenly the pen will mix the whatever inside the factory, then they will do it. Instead of having a 5 color, you can have probably maybe 100 of color to customize for your car, right? So that's the Industry 4.0 and so on, right? So you have a lot of other benefits. So but the meaning, the idea is that for the company, for industry, mainly you need to benefit both, the industry, the key player, and the consumer, right? The enterprise and the consumer, right? So because it must be a win-win situation. For example, here you can maximize your return of capital investment, right? For example, you need to increase your profit, obviously, but you need to have increase the customer experience. And so in this case, for example, here, so I want to have a blue pink. I don't know what, black pink is very popular. I don't know, this maybe Korean pop, black pink. But let's say you want to have a blue pink for whatever reason, right? A blue pink color for your car. So the customer can order that. So as you can see, the industry or the company or an enterprise can increase their profit because more people, they can even charge more for the extra colors, and then the customer have their own customized color. So this is the thing that maybe Industry 4.0 can enable. Is maybe feasible now or possible now, maybe not yet, but this is the promise now. All right, next is the Society 5.0. I'm not sure whether because it's already new, it's still new for me as well. This is actually initiative from Japan. Okay, I first heard about this when I attending a seminar by Hitachi, right? Because we have a collaboration with Hitachi. So Hitachi Japan. So this is a seminar by Hitachi. Apparently, this Society 4.0 doesn't even have a Wikipedia entry. I just want to copy Wikipedia. I cannot find it. Maybe somebody can create, because it's got new Wikipedia entry for this one. So I have to go straight to Japan website. This is a cabinet, office of Japan, basically Japanese government website. So basically, it's a concept put forward by the Japanese government. This is a Society 5.0. and there is a vision of a new society, and to make and to make some effort, whatever, to realize this concept. Okay, and then it is basically a human-centered society that balance economic advancement with the resolution of social problem by a system that highly integrate cyberspace and physical space. This is based on the website. Okay, I just taken this literally from the website. So I hope you can understand the definition here. Basically, what they're saying, they want to maintain a sustainable society where everyone can live a safe and fulfilling life. Or this is another definition by Hitachi. Okay, I'm not sure whether you've been to Japan or not. Like I mentioned, I've been to Japan. If you go to Japan, for example, your Google Map suddenly become Google Map plus, right? Or I call it Google Map on steroid. So basically, this Google Map can do not only your traffic, real-time alert, whatever. I can even know exactly. Let's say I'm going from Tokyo to Yokohama, for example, right? Yokohama is a place. It's not only a tire brand, right? You can go to from Tokyo to Yokohama, and then you can even know exactly what train to take. And then you can choose whether you want to have a mix of train, fast train, slow train, or the slowest train, because in Japan they have a few type of train. So you can, or you can mix with the bus. And every of these schedule actually is mentioned inside your Google Map. But you cannot have it here in Malaysia because the infrastructure doesn't support it. In Japan, it is by default. Okay, you don't need to download separate apps, whatever. You just use your existing Google Map. And then suddenly your Google Map in Japan, because they have a lot of data, and actually the company that provide this service actually Hitachi itself. So that's why Hitachi, I think they are very very active on this area society 4.0. So that means you can even travel easily without knowing any Japanese. Normally, if you travel maybe 10 or 20 years back, you have to ask around, and maybe the operator, especially if you outside Tokyo, they don't know how to speak English, right? So you need to do the translation, whatever, right? But in this case, you don't need to interact even with the operator, because all the information is all inside your phone, if you're using phone or your tablet or your PC. They're available in real time, right? So they're changing every second. You don't need to wait. You don't need to refresh even. They just keep changing every single time, right? So yeah, it kind of Waze or Google Map plus. All right. Okay, I think that's the introduction for the Intensive 4.0. All right, and this is the ladder or the step for the certified museum I taken from the Hitachi website. So you have this coexistence with nature, and then you have the development of irrigation, not only hunting. Then you have herding, or you are a shepherd. That's the fundamental of agrarian society, right? And then you have this invention of steam locomotive. Then you have this invention of computer, this information society. This is probably where we live in. So everything is connected, right? Even if you don't go to your workplace, you still can do your job. Like me, I'm teaching from my house, right? You can do that. And then, but this is society 4.0 where you have a super smart society where, like I mentioned, example of this Google Map, right? You can have a real-time information. What is the best possible way, the cheapest way, or you up to you. For example, if you want to during like I mentioned just now, if you have this lunch meeting, if you have lunch meeting from Tokyo to Yokohama, for example, right? You can do that because you know that exactly when the train when the bus is going to, and then you can plan accordingly based on your information, right? Before that is going to be, I have to rush to arrive at the destination because you're not sure whether the train will be delayed or not. Okay, all right. So this is kind of thing that you can possibly do in Japan or in this super smart society 5.0. Okay, and enough about Japan. And actually Malaysia, we have our own aspiration. They call it. If you watch the news yesterday or maybe the day before, the Prime Minister of the government announced this My Digital initiative, right? So this is an initiative, national initiative to successfully transform Malaysia into digital-driven, high-income nation and regional leader in digital economy. All right, and the Malaysia Digital Economy Blueprint spell out the effort and initiative to deliver the aspiration of My Digital. Okay, actually you can download this blueprint, available for download. I think it's about 100 plus document prepared by Economic Planning Unit. I think it's Prime Minister Department or Finance Minister Department. So you can see, actually the purpose of this blueprint is to chart the trajectory for Malaysian economy and build the foundation to drive digitalization across Malaysia, including bridging the digital divide. So I'm going to talk about this digital divide maybe towards the end of the seminar talk. All right, yeah, this is as you can see, this is the long list of Malaysian digital economic journey. As you can see, this is the start of MSc Malaysia. If you remember, actually you became part of MSc, Multimedia Super Corridor in 1996. I still remember when I was a student, and then I got very interested into networking, and I did my master in network security because I read about the book written by I think Alvin Toffler, The Third Wave, if I remember correctly. So actually, this Alvin Toffler is a consultant to Malaysian government to come up with this MS. It's a very nice book. If you want, you can read this. I'm not sure whether it's available online, but you can probably borrow the books from the library. It's a thing, the Third Wave. So this kind of foresee a lot of things that I'm talking to you now, even up until now. It's already mentioned inside the book, relatively speaking. Briefly speaking, right? So yeah, as you can see here, a lot of initiative has been done by the government, especially up until now National 5G Task Force. And then you have this fiberization, industry forward, and then you have this smart city framework, and you have a shared prosperity, and obviously this contribute to the my digital kind of initiative. So as you can see, it become more rapid as you come to the 2020 and 2021. Now it's become more rapid. You see a lot of more initiative because people or the government and the people realize about the what you call it, the importance of digitalization and the computer network enabled by the computer network and the internet, right? Okay, so basically I think that's finished on the overview and the motivation of the the current initiative by the international and our national government. So now I think we can go to the what is internet, right? Actually, if you want to know, actually internet is a subset or in the form of computer network. But obviously, this internet is a big computer network where you can connect to everyone regardless of the place. Even you can even connect to the Mars now. Actually, Mars is connected to some extent to I'm talking about the planet very far. From it will take probably, if you want to travel there, probably take you several months. But if you are using internet, you probably can get there in few minutes, right? Or maybe a few seconds if you want to communicate to the Mars. There is a robot now, on the Mars by US and by Chinese government. Right? You can check on the news. And there are, even you have a UAV, helicopter flying there. At the moment, they already perform few flights in the Mars and they communicate through the internet. Okay, but what is this internet nut and bolt view? Okay, so we have two views. We have a nut and bolt view and we have a service view. Nut and bolt is basically what is really the recipe or the making up of this internet, right? Okay, as I mentioned, internet is a special case of computer network, right? So as you can see, you have a billion of connected computing device. You have a host and system. You have running network apps, and then you have this communication link. You have a fiber or copper or radio, wireless radio, and you have a satellite. You have a transmission rate, which is the bandwidth. As you can see here, this is the mini internet, right? Or mini computer network, if you like. But because this is supposed to be over the internet, so this is a computer network based internet. So as you can see here, you have this what you call it, the end system, and then you have this which is this mobile, and then you have this institutionalized network. It's just like this UPM, right? For example, UPM is this institutionalized network is a academic institution, and then you have this global ASP and the regional ASP home network. So, for example, if let's say you go to Singapore or Thailand, right? Yeah. So if you want to connect to UPM, you want to do, you can. I'm not sure whether you know that for UPM lecturer now you can perform. Because now COVID is 100% online, right? You can perform, I think, up to 20% of your teaching. Let's say you go to conference, it's normal for lecturer to go to conference, international conference once in a while. So let's say you have a conference in Singapore or Thailand, you want to teach remotely, you can do that. And then let's say you are in Singapore, you want to teach your class, you can just connect through the global ISP. This basically you can buy this 5G or internet card from for 1 week or maybe for 1 day, depend on your arrangement. Let's say you go there 1 week, and then you can have this connection to the Singaporean ISP. ISP stands for Internet Service Provider, and then they will connect to the regional one. This is probably inside the Cyberjaya, and Cyberjaya is connected to UPM. For example, if UPM using telecom, so it's going to be your regional ISP is going to be telecom, or in global ISP, maybe in Singapore they call it Singtel. And so on. Okay, so this is the idea. So the idea is that as you can see, you have this is the what you call it. We're going to see that this is called end node. This is a core node, end node or edge node they call it, and then this is a core node, and then you have this in between they call it access. Okay, right. We're going to visit this again. Right. Okay, this is mainly the communication link, right? We call it access, as we're going to see later. Okay, this is fun internet connected device. All right, as you can see here, you have this IP Internet Protocol picture frame or IP frame or Internet enabled picture frame. You can buy this. Actually, you can buy this using Lazada or whatever, Shopee. I think they already sell this thing. And then a web enabled toaster. Monitor energy use. I'm not sure whether you know about it. If my house actually, they are they are already my 10B meter, electricity meter is already what you call it, connected to the internet, because they already changed my old meter with the internet enabled meter. I'm not sure every house, but I believe my house and my sister house in Shalam, they already enable with this internet enabled TNB. So they can control and read the meter reading in real time. They don't have to wait until 1 month, for example, right? They can do that. Okay, and then you have this Slimbot watch control TV remotely. So this is like your Astro box or whatever, your Unify box for the TV, right? And then you have internet refrigerator. Yeah, this is what you call it. You can get your fridge connected to the internet. Let's say you're low in milk or in any food. Your internet can order what you call it, Food Panda or whatever. Then they can send to you. And then you have this internet phone, for example, inside your office, or even now you don't even have a internet phone. You have this online phone inside your phone. That can be this internet phone actually become old, because basically putting internet phone, because your phone is internet phone now. Because you can for example now, if if you install the application, I hope everyone install this application by the by IDEC. Can't remember what is it called. I'm not sure you can see this is a IP phone by IDEC, Protacrom, right? I'm not sure. Can you see it? I hope you can see. Boleh ya? Right. And as you install this, you can, if people call the landline numbers, not my mobile number, they'll be directed to you. So I don't even need internet phone. There is no internet phone inside my office. If you call my number, I think 03, can't remember exactly the numbers, but if you call my number, then we direct it to my phone. So you can call me anytime, but obviously people normally don't call, they just use my mobile number. All right, that's fun device. All right. Okay. Next one is a right. Okay. Still not at both view. So if people ask you what is internet, people say, oh, you attend the seminar or you attend this computer networking class. what the meaning of internet? Internet is basically a network of networks. It's not very helpful, isn't it? I mean, what is internet? Internet is network of networks, basically, right? So basically, it just interconnected internet service provider and all their customers, right? It just what you call it? It just accumulation, or integration of a lot of network. That's what internet is about. Okay. If you have your own computer network, for example, like military, they have their own computer network, so this doesn't call internet. It's just military network, for example, right? But if you connect the military network, then the military network can become part of the internet. Okay, and then you have this what you call it, protocol. Protocol is just like a language. People like human, you need a language to communicate. Protocol is just a rule, regulation, or language to communicate between between the device and the nodes. And then, of course, obviously, you have an internet standard. Internet standard is what defines this protocol, because you need to agree. Right? It's just like when you have a language, you have this DBP, right? Dewan Bahasa and Pustaka to standardize the language. Otherwise, for me, I'm talking Perak, for example, and then and other people talking Kelantanese. I probably cannot communicate with this, with these Kelantan people, right? Because we have a different language, right? And for example, when I went to Kelantan, they asked me, sudah tubik, and was asking my friend where he's gone. They say tubik pergi pekan, something like that. Right? Tubik mean, in Perak doesn't mean anything. So in Kelantan mean that keluar, you're just going out, and then tubik mean going out, right? So this is a kind of thing that people need to standardize. So we have this DDP to standardize the Malay language. Similarly, internet have this standardization. They call it IETF, right? Internet Engineering Task Force, and then you have RFC. RFC is a kind of before IETF standard. You have RFC, and the fun fact is that most actually the standard, they're not become internet standard. They just become IC, but it's good enough. Okay, so you have this, and the next one is a service view, right? If you have this, what you call it, from just now, it's about the mechanism, the nut and bolt view. How about the service view, right? Because most of the consumer or the user of the internet, they don't care what is inside the, they don't care whether there is a router or switch inside the internet. They just want, can I buy the food over in the internet, right? Okay. Some even of them, they don't even care. Is it Food Panda or is it Grab? I don't care. I just want food delivered to my house, right? So they don't care about the mechanism. So this is a kind of service that we're talking about. So this service actually is an infrastructure. Obviously, it's hardware and software infrastructure that provide the service to application like web, voice over IP. I mentioned about the IP phone provided by the IDEC, UPM IDEC, and then you have email, games, e-commerce, social nets, and so on. And then you provide programming interface to apps. For example, if you want to do some Android application, for example, right, or mobile application for food delivery, so you need some kind of programming interface. This provide the service to the programmer or to the company like Foodpanda and Grabs to use or to access your phone, right? So, or your mobile device or your PC. So hook that allows sending and receiving app program to connect to the internet and provide service option analogous to poster service. So this is the service view, and it is the same thing. That as you can see, the picture that doesn't change. It just now is a mechanism. This is more on the service level. Oh, sorry. So you have this protocol. So as I mentioned, what is a protocol? Protocol is basically just a language that you have to agree, and then this protocol provide the rules, regulation, and the proper way to connect to each other. So actually it's defined format, order, message send, receive, among network entities, and action taken on message with transmission and receive. Okay, but network protocol is mainly for the machine, even though your phone, right? But actually your phone is a machine. Even though your phone belongs to you, actually your phone is a machine. So it's meant for the machine, right? All right. Now you have this example. In this case, you have people connecting. Let's say this is at least talking to Bob, right? But hi, you got the time, and now okay, the time is 2:00. So similarly, if you have the internet protocol, in this case TCP, actually the internet protocol we're going to see later actually called TCP/IP, and then for you have a connection request TCP, and then you have connection response, and then you have this website, for example, and then the website will send you file that you requested. So it's kind of similar to human, all right. And then and then you have as I mentioned before, this is the next one, the network edge, right? Look as architecture, all right. So what is a network edge? Okay, as I mentioned before briefly, we have three type of component. If for example after the seminar you don't get anything, I hope at least you got this three main component of the computer network or the internet in general. So you have a network edge, or sometimes they call it node, edge or node. And then you have a access network, and then you have a network core. So these are three things, right, that you have to remember. One is the edge, one is core, one is access. Access is basically what is connect between the edge and the core. Okay. For example, if you meet someone from Petronas, right, because Petronas is a very big and multinational company, probably the biggest company in Malaysia, and one of the biggest company in the world, right? I think Fortune 500 company. So if you have a friend that working with Petronas, I think maybe is useful. You can you can ask, oh, did you work at Petronas? They say, oh yeah, I'm working at where do you work? They say, I'm working at Petronas. And then you can ask, oh, in Petronas do you work upstream or downstream? So what it means is that when you say us is you working upstream, normally you working with Petronas Carigali or whatever, doing something near the source of the oil, right? Because Petronas is mainly oil company, right? So you have this kind of what you call it, upstream, mean that drilling and Carigali and so on, right? So for the downstream, for example, that the one that you go to this KLCC, right? The one who live or work near KLCC, or a lot of building, actually Petronas is building another building close to that KLCC. Actually, half of the KLCC now has been rented out. But anyway, if you work near that KLCC, for example, you're talking about your work in the downstream, right? For example, or if you want to see this Petronas, for example, Petronas Dagangan, right? The one who sell the petrol to us, the petrol station, they all consider downstream. Similar to here, you have a edge, like like kind of downstream, if you like, and then you have the core, which is kind of the upstream, or in this case, this is the managed by the ISP, right? Okay, but you have to be very careful. For example, this is a very popular question. If you're inside the class, it's going to be an exam question. So for example, there is a question: if a server is part of the core or part of the edge. Okay, so the answer is that the server is part of the edge, not the core. All right, because the server actually, you have a client and server, right? And we're going to see that actually in computer network, and they have this client and server paradigm. Later we have this peer-to-peer paradigm. But anyway, you have a client and server paradigm. The client and server is both considered network edge. It's not server is not network core, even though you have the server inside the ISP. But normally when you talk about server, you talk about Amazon server, not the ISP billing server, right? So normally when you say, oh, I'm connecting to the Amazon server, the Amazon server is not your core network. Amazon server belong to your network edge or network node. This is the clarification. This is very important. Hopefully we can understand this this distinction. It's very useful for the discussion and to learning the thing. All right, so you have this access network and physical media. Access is basically how you access it. For example, for example, if you go to a new country like Japan, for example, or in Thailand or Singapore, you buy this 5G connection. This is basically you're buying access, to the internet service provider. So you're buying the access network. You don't buying the SIM card. Actually, you just buying the access, because some of the network provider, they don't even have a SIM card, right? They just provide you with the with some link, whatever, right? And then you authenticate, then you can even use your own SIM card. You don't need to change the SIM card. But it's just the way how the ISP work. but most of the ISP, they require you to change the SIM card and so on. That's why most of the phone now, they have a double or two SIM card, right? And then one of the SIM card can be used for storage as well. But if you go to overseas, you can take out your storage and that function as a SIM card. But I think the modern phone or 5G now, you probably don't even need, second SIM card. They can just enable you, automatically based on the code, right, or credential. All right. So and then as I say, is this assessed probably mainly by your SP. And then you have to keep in mind your bandwidth and is it shared or dedicated. So you have to keep in mind about this when you want to buy. For example, is it limited or unlimited and so on. So you have to ask your provider, right? For example, if you want to provide online class, maybe you need to buy a lot of bandwidth and a lot of quota for the bandwidth as well, right? Bandwidth is the rate, the quota is the total amount of things. So if you're going to teach while you are overseas, you probably need to buy a lot of quota and maybe unlimited if the price is good enough, low enough. Okay. All right, and you have this network digital subscriber line. I think I'm not going to go detail on this. This is a very old conventional digital subscriber line. Mainly if you have the you live in the remote area, I'm not sure remote. What is the remote area in Selangor now? I'm not sure. Is it Banting? Banting is remote area. I'm not sure. Let's say you live in Banting. There is no Unify or fiber line like I'm living in Bandar Siputra. This one of they claim, I'm not sure this is true or not, one of the first housing that have a fiber, right? So that's claimed. So now actually I never use the DSL from my house, because they already have fiber by default. Some of the remote place, they don't have enough, for example, subscribers. Normally they need to resort to DSL because DSL is using the old telephone line, but obviously it's limited up to maybe 1 megabit per second, or 10 megabit per second on average. They use your telephone line. What they do, basically, they have a splitter, a portion of that dedicated for your telephone line, a portion of it dedicated to your internet. But it's not that good compared to the your normal, your normal fiber. Okay, so this is typical access network for your home network. So this can be your DSL modem, or can be your cable modem, or can be your Unify modem, up to you, right? If you subscribe to Unify, in my case, this is my Unify box of, they have a fiber connected to the main, and then I have my own router, firewall. Normally I buy my own because it's more flexible. I buy from Assoc, whatever, right? Some third-party one, so they can connect to this. You cannot change this one because it belongs to you, telecom, right? But you Unify, this is belong to that's why you can change this one. So up to you. And then you can connect this using Wi-Fi. The latest one is Wi-Fi AX, right? If you want to buy Wi-Fi access now, don't buy AC, the old one. I have the AC one. I haven't upgraded to AX, but AX I think is the latest one. And it should provide you with more bandwidth, because this thing doesn't change. All right. For example, if you have a 300 meg Unify or 1 gig now, I'm not sure. Unify doesn't support 1 gig. Maybe soon support 800 meg, I think, maximum. So, but you can connect to this 1 gig box, for example, right? And then yours, if you have AX, you can support more than 1 gig, so it's okay lah. If you use the old one, for example, like 802.11 AC, or even before that, G, something like that, you do. Even you have a box. I got a problem last time. I just upgrade. Actually, they give my account automatic upgrade to 300, but I have this old box which is only 100 meg. So actually, the bottleneck is not my, imagine my router is slower than this one. So after I upgrade then to AC, now I can get full 300 meg. Okay. So again, if let's say I got 1 gig, then I need to probably upgrade it to AX, which is probably can support more 1 gig connection. Okay. Now, this is enterprise network. Network. This is like UPM, organization network. You have this institutional ISP connected to the telecom or Unify in this case, and then you have this web server, for example, UPM, they have their own web server, and then you have a local area network, they call it LAN. So this, you have a faculty engineering, you have faculty of agriculture, you have, I'm not sure how many faculty you have in UPM, maybe, I don't know, 18 or something like that. So every faculty have their own thing. And then obviously typical use in company, and you have a 10 gigabit transmission rate. Actually, UPM, for your information, UPM have 1 gig now. But actually, one of my students doing research for the 10 gig, so she need to go to UM for testing, right? Because we have collaboration with UM. So UM support up to 10 gigabit per second transmission rate. Actually, they are still in the testing phase. So hopefully soon, maybe next year also, we're going to upgrade to 10 gigabit per second. I'm talking about the main line to the ISP, in this case telecom, or for the 10 gigabit is probably to the MyRAN, which is a Malaysian university or research network. Okay, right. You have this, we have another maybe few minutes before we stop for break, right? So you have this wireless access network, you have wireless LAN, and then you have a wide area wireless network, which is using the cellular, can be, or now for IoT, the popular wide area wireless network is LoRa, long range, wireless, right? So yeah, for wireless, you have this wireless LAN, as I mentioned, you have this BGN, but now you have AC and AX, right? So and then yeah, for wireless access, you have this cellular, which is quite slow. But if you go to Taiwan, perhaps actually I use their 5G connection. It's very cheap one. I bought it for a few weeks, or 1 week or 2 weeks, and they can access 300 meg. Imagine I can access 300 inside the train. I can access 300 megabit per second, which is as fast as my home. Believe it or not, right? In my house now, my connection is not very good. I can access probably 5 meg at most using my 4G. But in Taiwan, if you doing you have your 4G or LTE, you can connect up to 300. I mean, it's normal in Taiwan. Your cellular line, or your 4G line or LTE line is faster than your home. So yeah, it's kind of your home network become redundant. You can just access using your phone. All right. Anyway, there's not even 5G. We talk about 5G later, but this is for 4G in Taiwan. All right. So I think should we stop now for a break, and you can watch the video, interesting video from Ericsson, Packet Warrior, on the maybe you can watch from the link, or maybe you can broadcast from the Google Meet, because last time I think broadcast I cannot get the sound working. Sham, can you help us? Maybe you can.
Ya, saya boleh sharekan link video.
Link maybe, yeah. I think broadcast maybe is not very. Maybe the sound problem. I'm not sure. Last time I have problem. So maybe you can go to the link and private Sham, and then this is about 13 minutes. You can just click on it, and then maybe we come back 15 past 4. Is it okay, Sham?
Boleh, insyaAllah.
Okay.
Pak Suku kita sambung balik.
Yes, Pasku, we come back by 4:15. Please make sure you check the video. This is a very interesting video. Even I watch it more than 10 times, I still, very interested, with this video. Very nice video by Ericsson. It's an old video, but still very informative. All right, thank you. See you in 15 minutes.
Okay, thank you, Doctor. We are rest around 4 until 4:15. InsyaAllah, I have shared the video link in the message. See.
they make their way into the corporate intranet and head for the router switch. A bit more efficient than the router switch plays fast and loose with IP packets, deadly routers along the way. A digital pinball wizard, if you will.
Plenty of space, plenty of opportunities, plenty of things to explore and places to go. Thanks to very little control and regulation, new ideas find fertile soil to push the envelope of their possibilities. But because of this freedom, certain dangers also lurk. You'll never know when you'll meet the dreaded ping of death. A special version of a normal request ping, which some idiot thought up to mess up unsuspecting hosts. The paths our packets take may be via satellite, telephone lines, wireless, or even transoceanic cable. They don't always take the fastest or shortest routes possible, but they will get there. Eventually. Maybe that's why it's sometimes called the worldwide wait. But when everything is working smoothly, you can circumvent the globe 5 times over at the drop of a hat. Literally. And all for the cost of a local call or less. Near the end of our destination, we'll find another firewall. Depending upon your perspective as a data packet, The firewall could be a bastion of security or a dreaded adversary. It all depends on which side you're on and what your intentions are. The firewall is designed to let in only those packets that meet its criteria. This firewall is operating on ports 80 and 25. All attempts to enter through other ports are closed for business. Port 25 is used for mail packets, while port 80 is the entrance for packets from the internet to the web server. Inside the firewall, packets are screened more thoroughly. Some packets make it easily through customs, while others look just a bit dubious. Now, the firewall officer is not easily fooled, such as when this ping of death packet tries to disguise itself as a normal ping packet.
It's okay, Norm. It's okay. No problem. Have a nice day. Be out of here. Bye.
For those packets lucky enough to make it this far, the journey is almost over. It's just a lineup on the interface to be taken up into the web server. Nowadays, a web server can run on many things, from a mainframe to a webcam to the computer on your desk. Or why not your refrigerator? With a proper setup, you can find out if you have the makings for chicken cacciatore or if you have to go shopping. Remember, this is the dawn of the net. Almost anything's possible. One by one, the packets are received, opened, and unpacked. The information they contain, that is, your request for information, is sent on to the web server application. The packet itself is recycled, ready to be used again, and filled with your requested information. Addressed and sent out on its way back to you. Back past the firewall, routers, and on through to the internet. Back through your corporate firewall. And onto your interface. Ready to supply your web browser with the information you requested. That is, this film. Pleased with their efforts and trusting in a better world, our trusty data packets ride off blissfully into the sunset of another day, knowing fully they have served their masters well. Now, isn't that a happy ending?
Okay, Assalamualaikum. Kita dah habis masa tadi. Dengan video dah habis tadi. Terima kasih Cik Kim share video. Okay, boleh Dr. Shaiful boleh sambung semula.
Alright, okay. Thank you very much, Mr. Hisham. Welcome back. I hope everyone enjoy the video as much as I do. Right, okay. Actually, some of the information that we're going to share later on is going to actually already being covered by the video. So I think it's kind of expedite the, hopefully the understanding process, because the video I think is very, very informative. But anyway, I just continue with the what you call it, with the lectures, with the slide. All right. So for example, here is you have a scenario where a host want to send a packet of data. Okay? Maybe if you're not familiar with the term packet, packet is the what you call it is a group of bit or information. We call it data, but in network we call it packet. It's just something like your DNA, right? Inside every human, we have DNA. So packet is something like the basic information of network. We call it packet. Okay, and then this you have a host. For example, here you have host sending to the switch, right? Okay, and then you have this text application message. For example, a video, an image, or email, or whatever, a text file or document file or your CV. It's break down into smaller chunk known as packet of length L bits. Okay, and transmit packet into access network at transmission rate R. So as you can see, this is to your access link inside your house or towards your ISP, and then you have this link transmission rate, or they know it capacity or link bandwidth. So basically, the capacity, or we call it the bandwidth, is the transmission rate of the packet itself. Okay, all right, and then you have this equation. For example, the delay, right? So as we're going to learn soon, is that this delay and bandwidth is the two very most important metrics. Actually, it's two most problematic metrics. Okay, depend on how you look at it, whether the glass is full or half empty or half full, right? But anyway, these are two main concern of the internet, where you have this bandwidth and delay. You obviously you're going to have a good network to have a good bandwidth and minimize your delay, right? So in this case, you have a delay equation to take the delay. You have this time needed to transmit L bit packet into the link is L over R bit. Length is the length of the bit of the packet, and R bit is the rate. Okay, for example, if you have a Ethernet LAN, not internet LAN, Ethernet LAN, which is the local area network Ethernet. If you have 1,500 bit, and then you have this 1 kilobit per second, then you can have 1.5, something like that. So that's the rate that you can have, right? Depending on the length of your packet information, right? And then because this is you have a bit over bit per second, you have a second as the unit, and then the delay, obviously delay is in seconds, so it makes sense to have a unit in second. Okay, so we go next to the physical media. We're going to continue about the delay, soon. But anyway, before we go to the delay, and we need to look into the physical media. Okay, actually, most of the especially in engineering, most of our subject, they are dealing with physical media, right? And you have wireless, and you have fiber, right? Photonics based, and so on, right? And this physical media normally is governed by they call it EM, electromagnetic propagation. Okay, and this is the medium. The physical media is the medium, how the wave transmitted from one end to another end, and they move very fast. Okay, they move as fast as the light, which is 3 times to the 8 to the power of 10 to the power 8 meter per second, which is if you know how fast it's probably from sun to the light travel from sun to earth in about 7 or 8 seconds, or maybe less, right? So you have very, very fast, right? Like the video mentioned, you can go around the earth at a drop of a hat. So it's very, very fast, right? You can circle the earth few times, right? 5 times in 1 second, right? So that's how fast the bit propagate, right? So there's a bit propagate between transmitter and receiver pair, and then you have a physical link what lies between the transmitter and the receiver, and then you have guided media, which is the wired, we call it guided or wired media, and you have this unguided media, which is the wireless one. Okay, so the guided media or the wired is copper, fiber, and the coax. I hope you are familiar with the copper. You can see the picture of the copper, we call it RG45 here, and then obviously we don't have the. Maybe later we're going to see the picture of the fiber, but fiber is a kind of the faster one, and then you have a coax. We call a coaxial for microwave whatever, transmission. If you're not familiar with your coax, you can go to your Astro box. If you happen to have an Astro box at your house and you look at the back of your Astro box, then you will see this coax kind of like two centrical, double centric, cable, which we have a couple in the middle, right? So that's we call coax or coaxial, right? So you have basically a two, coaxial cable with two center core. They call it coax. You have this unguided media, which is wireless radio, which is very popular now because, to be honest, people don't want to, connect to their USB anymore. They even use Bluetooth and Wi-Fi and so on. So if you go to, you go to the to hotel, for example, right? You don't ask for the wire, right? At the time, I remember if you go to the hotel, you need to even pay or rent the cable, right? But now nobody asks for the cable anymore. They just use Wi-Fi because it's good enough, it's fast enough if you want to just browse to the internet, right? And then you have this, as I mentioned, you have this twisted pair. This is the most popular one, two insulated copper. You have a category 5 and 6 now, right? They can support up to gigabit per second. But the problem of this copper or the twisted pair, the distance is going to be limited. There's not going to be far. Probably you can go up to 50 or 100 meters at most, and then you're in trouble. Okay, so the solution for this physical media, normally you use a fiber optic cable. Okay, so fiber optic cable, as you can, this is people holding this cable, but actually this is the raw cable. Maybe maybe we can find a better picture of this. But basically, this fiber optic cable is future proof, right? For example, I have one cable connected to my ISP network, right? So this cable actually is future proof. That means I don't need to upgrade this cable. Once I install it, when I will install it, it can support up to at the moment my bandwidth is around, I can't remember exactly. Let's say at the moment the bandwidth is 10 meg, and then they upgrade 30. Now it's 300, right? So I don't need to upgrade the cable unless it's not like I'm upgrading my gateway. Remember, I have this G wireless Wi-Fi G problem, and I upgrade to AC. Maybe soon I'm going to upgrade to X. But for fiber, it's a future proof. It doesn't have. I mean, maybe in the future I got 1 gigabit. I don't need to upgrade, and then I go for 1 terabit. I'm not sure whether you can appreciate the meaning of terabit. Terabit is basically 1,000 gigabit. So it's going to be more than 1,000 times what I have now, which is 300 meg. I don't even have to upgrade my fiber. This is the beauty of fiber, because it's basically a future-proof network. It's bad for the company. If you are selling, fiber optic company, probably is not it's not a good idea, right? Like iPhone, you change every few years, yeah. So that's why Apple is very rich. But if you have a fiber optic company, then you cannot sell a lot of fiber, right? So yeah, maybe it's a good idea to invest in non-fiber technology. Right. Okay. Now this is kind of the advantage of the fiber, but the coaxial cable, as I mentioned, if you haven't seen any coaxial cable, it's like something like this. Coaxial meaning that they share a common axis, and then you have the copper in the middle. It's essentially a copper base, but it's very popular in the US because US use this, but we don't use this. I think one of the Indian company trying to propose to Malaysia, but doesn't take off because we don't have this infrastructure, and then to invest on it is costly, and might as well we go straight to the fiber, because fiber is future proof. Coax is not future proof. Okay, that means you need to change sometime in the future. So I wish my car is future proof, so no need to buy a new car every few years. But it just the way it is, fiber is very very interesting and very powerful technology, and it's very good technology. Right. So and then you have this radio, and then even though fiber is okay and then very fast, you can even go for terabit link if you want to. Right, it's feasible, but again, it's not. You don't want to carry your fiber to your, cafe, whatever, having a meeting in the cafe or in a restaurant, whatever. Right, it's kind of inconvenient, right? So you just want to bring your device, which is wireless, come very handy. All right. So in this unguided media, or we call it wireless. Signal carried in electromagnetic spectrum, the same in wired as well, still carry in electromagnetic spectrum, but that one is guided. This is not guided. You have no physical wire, and then it's bidirectional propagation environment effect. But the problem is that because it's unguided, so you have a lot of problem like reflection, obstruction, and interference. So a lot of research and innovation coming into this kind of this problem to solve this problem. That's why we have this 5G now, and this 5G, as you can see, it can go up to 300 meg, which is 4G cellular. This is what I mentioned to you as experience in Taiwan. This is no joke. As far as my, I still have the screenshot, I think, and still this is as fast as my home, right? From Unify, which is wired, so they can go up to this 300 meg. They call it 4G or LTE advanced there. And then you have this 5G up to 20 gigabit per second. So you're wondering how come they improve a lot here, right? Imagine, right? A 3G is around 5 up to 5 meg, maybe 10 meg, and then they jump to 300 meg, and then suddenly they jump to 20 gigabit per second. Actually, the secret behind this, or actually they can go to up to 20 gigabits because they're using what they call it, the technology called millimeter wave, right? It's not normal wireless that we have this 2.5 gigabit, which is inside your house. You have both, right? 2.5 and 5 gigahertz at 2.4 to 2.45 or 2.5 gigahertz, and you have this frequency, and then you have this 2.5 gigahertz frequency. You have both, right? So and that one actually for the normal 5G cellular. This one, because they deploy this what they call millimeter wave, and then what happens is that in the near future you're going to have a lot of pole, right? And instead of you have a base station far away or distant from each other, you're going to have a lot of pole, maybe similar to or maybe they can just put inside your your lamppost, right, near your house, right? So every lamppost will become a base station. So that's why they can get this speed up to 20 gigabit per second. So it's not going to be sooner. I think, paling, if the most maybe 5 years, or maybe they're going to install this and then you're going to get it. But don't count on it because it's going to be cost a lot unless you're living in small city or big city in KL or in Singapore. Maybe you can experience, because it's going to be costly to the service provider to implement this. I think Malaysia have this gender initiative. They kind of like private sector and government. They're trying to kind of pull the resource or capital, the money to install this infrastructure, but still in the early initiative. All right, and then you have a satellite. I'm not sure whether actually you're familiar with satellite network, but satellite is not very very fast. There is a new and then the delay is very bad because they are very far. About 40 kilometer. In the sky, right? So there are new proposal. I think from US, from Tesla company. They call it. I can't remember the company by Elon Musk, but the company they have this new satellite configuration that can support much higher, maybe up to 1 gigabit per second. But there are a lot of satellite coming up there to provide that service. But it's going to come up first in US, obviously, because the investor, the company is in US. But maybe it will come soon to Malaysia. But maybe it's not going to be soon, right? It's going to be a bit later. All right, that's the idea of this radio. And then enough about the access and physical one. And then we go to the network core. Remember, this is the edge, right? And then the client and the server, they all belong to the edge. And then you have a core here. Cores belong to your internet service provider. You don't play around with the core unless you're working with internet service provider company like Celcom, telcos, Time Telecom or Telecom, and etc. Right? So this is a packet switching host break application layer message into packet. So this we're going to learn about this packet switching later on. It's forward packet from one router to the next, across link of path from source to destination. Each packet transmit at full link capacity. This is the idea of this internet or computer network they use now, they already move on from circuit switching to packet switching. We're going to learn about the difference on this technology soon, hopefully. Okay. Right. So this is packet switching. So because this is a kind of a shared medium, if you like, compared to circuit switching, it's kind of a store and forward. So basically, kind of keep the copy and forward, to the next, receive the copy for one interface and copy to the next. So basically, you have this, for example, like a switch or router. Normally they have, normally more than one interface. Then they need to store and forward to the next interface. And then it takes L over R. We learn about this is the delay, right? To transmit, push out, add bit packet into a link at R bit per second. Store and forward, entire packet must arrive at router before it can be transmitted on the next link. Obviously, there are new technology that you can do like a pass-through kind of thing without, but in conventionally, this is how they do. They all the entire packet need to be received before they can forward to the next interface. End-to-end delay, you have a 2L over R assuming zero propagation. That means you have to, for example, if you provide a ping, right? Ping you need to send to the destination and reply. So this is a 2LR because you have to end-to-end, right? From here to destination, or here client to the server. Let's say this server and back to the client. So you have if you ping here, basically you just test the connection here, and then you can see this, this delay effect. This is not going, even though it's going to be fast, as it's lightning fast, but still, let's say your server located in the different location or in different state or in different country will take a while, maybe a few seconds or a fraction of a second to get the reply. All right, one hop numerical example, you have L 7.5 megabit and then R 1.5 megabit. One hop transmission delay is 5 seconds. So 5 seconds is in terms of computer networking is forever, right? So if you, for example, if you're playing games or online, whatever, this not the acceptable maybe millisecond, maybe 50 millisecond, not 5 seconds is forever in terms of computer networking. Just giving you some example there. Right, so you have this packet switching, queuing delay and loss. As you can see, you have this two PC sharing, sharing this. The channel or the line here, right, transmission line. So you have this R is 100 megabit, and then you have a B, maybe similar values here or similar capacity, and then you have this link limited 1.5. As you can see, this is going to be Q here because the transmission rate kind of overwhelm the output, the input. Transmission rate overwhelm the output, so you're going to have a queuing and loss. It's kind of common when you go to the traffic, right, to the toll during a busy Monday morning, for example. Then you see a lot of people queuing at the toll. Similar experience here. So if arrival rate in bit to link exceed transmission rate of link for a period of time, packet will queue, wait to transmit it on link. Remember, you have to be store and forward, right? Packet can be dropped, lost if memory buffer fill up. So you can get a lost packet, and you can send again, right? But because this is a virtual world, you can send the same packet again. But again, if if the thing is real time, for example, you're watching a video streaming of Euro 2020 game, for example, right? Probably it's not going to happen. You're not going to send another pizza, right? So you just live with that loss. But if you're sending a CV, for example, your CV, then you need to resend the information because you don't want your CV to be corrupted. It depends on the application as well. Some of the applications, they are very loss tolerant. Okay, so now we go to the two key network function. You have this kind of this is a two key network call function. The main the two main function of the network core is basically routing and forwarding. So I hope you can understand the meaning, right? Routing means that basically you route from one place to another, right? And basically forwarding is between a junction. Okay, for example, if you're routing, you can consider this as your Waze or Google Map. Forwarding is you are the driver or your co-pilot giving you direction, turn left, turn right, move forward, and so on, right? So there's this telling you the direction, in between junction. So yeah, as you can see here, routing determines source, destination, route taken by packet. You have a routing algorithm, and this routing algorithm can be a shortest path, for example, right? Or maybe the cheapest path, depend on your algorithm, right? Normally it's the shortest one or the fastest one. And then forwarding, move packet from router to input, operate output. So forwarding is for this function only. So you might think that why not they combine this together, right? Why don't they separate this? It turned out that actually to provide a more efficient network, you need to separate this and to make it more faster, efficient, and flexible. They need to separate. This is the premise or whatever, the principle of software-defined network, where they kind of separate the routing, the control plane against the forwarding plane. So that means they have a very good kind of idea. So the funny thing is that actually I'm using this computer networking book. I given the reference at the end, and probably I can upload the thing. Actually, there's a textbook by Crosshair. I think I can recommend this textbook. Probably one of the best textbook in computer network, or probably in any subject. Very nice. So actually, I think if I remember correctly, I'm using from the first edition. Now it's 8th edition, right? Already 8th edition. They already given this separation in the beginning, in the first edition, even before the software-defined network become popular. So it's turned out that if you separate this, you can get a better, a performance and efficiency and flexibility. When you, maybe we can come back to that later. Right, alternative core. Alternative core is circuit switching. Why we want to know about this circuit switching, right? Circuit switching is essentially alternative to the packet switching. This is in the old days. If you have a telephone, this is the telephone system or telegraph or telegram system, not your software telegram, your apps. I'm talking about the old telegraph, that goes over the wire, right? So this is basically the old telephone network. They call it POTS, plain old telephone system, proposed by Alexander Graham Bell, right? And this become very popular, and then people use it for about 100 years, and then suddenly people propose, they find the limitation of this, and then then propose packet switching. So for your information, computer network, they're all based on packet switching, not circuit switching. We just learned this for historical reason. Okay, so now actually almost all the network that we have, they're all based on packet switching. As you can see here, the attentive core, circuit switching as opposed to packet switching, you need to reserve, right? You need to reserve the line, right, from end to end. So the advantage that you have a dedicated resource, a no sharing circuit like guaranteed performance, and circuit segment ideal if not used by core. So if there is no people using it, then it's going to be wasted. It's just like a parking, right? If you reserve your parking, even though you don't come to your office because you're sick or because of COVID, whatever, then nobody going to use your parking because it's reserved. It's similar idea, but it's not very efficient, obviously. Then it's commonly used in traditional telephone network, and actually people already abandoned this circuit switching network and move to packet switching. This is what computer network and internet use, right? As you can see briefly, that you have a circuit switching. This is doesn't matter. It's just like a cake. Whether you want to slice it one way or another, is going to be the same. So for circuit switching, you can slice using a frequency, or you can slice using a time. In this case, and then they just giving you the same bandwidth. Both, if you can spend 1 minute or a few minutes looking at this picture, you can appreciate that actually they are same bandwidth. Doesn't matter you go by frequency or by time. Okay, so that's a circuit switching. But the problem now is that people found out that the circuit switching is not very efficient, right? And then they proposed this packet switching network. Yeah, obviously, when people propose a new stuff or new idea and technology, it can work, it cannot. Sometimes it doesn't work, right? It depends on the technology availability at the time and the reception by the user. Depend, right? But if you have, if you have in normally in consumer market, it's easy. If you have a 10-time performance, right? Or you can have a 10-time cheaper price. Either way, if not both. If you both, you got a slam dunk or whatever, very nice system. But if you have a 10-time cheaper or you have a 10-time faster, you can easily beat the competition. This is what packet switching does basically, right? So it's provide more efficient and cheaper, cheaper communication technology. So that's why packet switching now become the default, monopolize the market compared to packet secret switching. So as you can see, let's say you have a 1 megabit per second, and then you have each user 100 kilobit when active, 10% of the time. Let's say you have user that use 100 kilobit per second every time it's active, but obviously the user doesn't use, like I mentioned, the parking not going to be full every single time. Sometimes the guy go for restaurant or going to eat for lunch, or maybe they're sick because of COVID and so on, right? So they're not there all the time. Okay, but the circuit switching, even though the user is not there, you need to reserve it by all means necessary, because it's reserved, right? You already pay for it, right? And then the maximum you can have is 10 user. But in packet switching, as you can see, you can, right, or maybe more. But again, if you have a more user, then you're going to have a problem. They're going to show you later on. So let's say you have you can have a more than 10 user, which is 3 times more in this case. 3.5 times more than the 10 user, and then because they are not active at the same time, 10% active at the same time is less than 0.004. This is very very minimum, right? This is about like very small amount of probability that they're going to be active at the same time. So basically you can support more users. So it's good. It's good for the industry 4.0 kind of principle. Is good for the enterprise, for the company. Is good, and it's good for the user. Right now, user can pay a cheaper price, hopefully, right? And then the user, the company, the enterprise can support more user, more profit, right? So it's a win-win situation. That's why this packet switching is taking off. Yeah. And then is packet switching a slam dunk winner? This is a US jargon because the textbook is made by US based professor, right, or author. So, but again, great for bursty data, resource sharing, simple, no cost setup, you don't need to reserve and so on. And then this, but the problem is that excessive congestion, possible packet delay and loss, as we see before, and we can see later how this packet delay and loss affect the computer networks, packet transmission, protocol needed for able data transfer, congestion control, and so on. Because because there are a chance that you have a heavy traffic, just like in your tolls or in your highway, right? There is a chance there is a heavy traffic, then there is you got a packet loss and packet delay, right? So if the packet delay is worsen, then it become lost, right? You have to delay first, then you can loss. Okay, I have a experience when I want to go to the meeting in the morning. I think Monday, can't remember, is it Monday morning? So when I want to go to meeting, and then I have a delay, maybe about take me 40 minutes to travel a few kilometers, or maybe 1 kilometer, and I have to turn back and call that I cannot attend the meeting. At the time there is no online meeting, it's a physical meeting, because for delay I have to go to KL anyway, because I just delayed, but lost, then I cannot go because it's already take too long. By the time I arrive there, the meeting already finished. So this is potential disadvantage of this packet switching. The question is that how to provide circuit-like behavior bandwidth guarantee needed for audio video application, still an unsolved problem. So if you can solve this, I think you probably can become millionaire or billionaire if you can solve this problem. It's a very difficult thing to actually the funny thing is that it's already solved inside the circuit switching. Say, why not we switch back to circuit switching? But no, cannot. You still need to use a packet switching, but how to provide this cheap, whatever service guarantee or quality of service, which is an unsolved problem until now. 100, if not 1,000 of PhD student or researcher trying to solve this problem. Still, they're still struggling to solve this problem because it's a hard problem. Okay, human analysis of reserve resource circuit switching versus on-demand allocation. So basically, yeah, human analysis as mentioned, like a parking, right? So you go to the parking, some of the parking is already reserved with the red line, whatever, right? You can just parking at the white line or yellow line. So this is the human analogy. Okay. All right. I think we go to this internet structure network or network. As you can see, NCTerm connect to the internet via ISP, internet service provider. You have residential company use ISP, access ISP intern must be interconnected. Any two hosts can send packet to each other. So anyway, how you connect to internet? Because internet, as we mentioned, is a network of a network of a network, right? So it's basically just a accumulation or integration of disparate network, and then you have this network of network is very complex, and then the evolution by economics and by national policy and so on. Let's take a stepwise to describe that. So yeah, I can quickly go to this picture. I hope you can see this picture properly and clearly. As you can see, let's say given of a million of access ISP, how to connect them together. So let's say you have literally million of internet service provider. Okay, and then as you can see how you connect. Can you connect this ISP to every other ISP? Remember that this ISP want to connect to to every other ISP in terms of because the server or the client can be anywhere in the world, right? Because it's universal access, right? Remember, all over the country connected to this internet. So if you connect to each ISP to each other, that it doesn't scale. You have O to N squared complexity, right? So if you know algorithm, complexity, this is a no-go. You don't want to use O N squared. It's going to be very expensive to maintain the connection. And then, yeah, and it's going to be prohibitive. Remember, the price need to be affordable to be attractive to the consumer. It's too expensive. Nobody going to use it, right? So yeah, the option is access SSP to one global transmit ISP. So this is better. Actually, you reduce a lot of this, this one-to-one connection, right? At least customer provider SPS economic agreement, and you have this some kind of, but still this is not very good. Because if there is a failure of one things happen, then there will be no connection at all, right? So the better way is to have more, this more than one ISP. For example, this is for Europe, this is for Asia, this is for America, for example, right? North America. So as you can see, this is much better arrangement, right? And then this is peering. They need to be, they need to pay each other for their peering. This is now you wonder if you pay your ISP where the money goes. Actually, they have to pay, or depend if they have this mutual consent that they probably don't need to pay each other because each of them consume each other traffic. Sometimes they need to pay, depend on their size. And then you have this internet exchange point. This exchange point is basically, to connect the different ISP from different places. And then you have the regional net here, and then you have this content provider network. You're wondering what this content provider doing across the board, across the ISP or network. You imagine content provider network is just like Google or your YouTube content, right? For example, if you watch, for example, if people in Malay-speaking community like Brunei, Malaysia, and Indonesia, right? Probably the video is normally going to be hosted close to the Indonesian and Malaysian region rather than, or South Asia region rather than host in US, because nobody going to watch, Malay, news or drama or content in US. If there is only, it's probably going to be very small. So mostly they're going to be provided close to the consumer, right? So this is the idea of content provider network, or sometimes they call it content distributed CDN, content distribution network. Okay, as you see, this is the very good thing. Sorry, I have a Taiwan ISP, and then you have regional ISP, and you have internet access ISP. Access ISP, if you like something like your Celcom, DG, and so on, right? So this Taiwan ISP is your telcos, maybe your Time Telecom, and Telecom Malaysia and so on. So you have this Google here, which as a CDN, Google on YouTube, as I mentioned just now. So YouTube will be based on your CDN. Right, and then you have this tier 1 ISP, ISP, and then you have content provider like Google. Okay. Yeah, as you can see, this is Taiwan ISP, Sprint in the US. Malaysia going to be similar like this, but obviously we are in a smaller scale. All right, and then you have this point of presence. For example, as you can see, this is the black and red one. This is a point of presence for the ISP. So this is only from one Taiwan ISP. For example, their competitor, let's say the competitor called, I don't know, in US they call it Orange or whatever, some other competitor. So then they have similar network like this, but probably different location or something like that. Okay. All right. Okay. We go to the next, delay, loss, and throughput in network. Because I think there's time limited, I'm just going to go through this very quickly. You have this, you're going to see how this delay and loss occurs. As I mentioned, first you got delay, then you got loss. Packet arrival rate to link temporarily exceed output link. So because it's not reserved, so the arrival rate can exceed the output rate. And then yeah, you have this a lot of delay. And then as you can see, they have categorized the delay to 4 types of delay. One is nodal processing delay. One is queuing delay. Another one is transmission delay, and a propagation delay. All right. Mainly propagation delay is easy to understand. Is due to the speed of light, right? Okay, like this one to the power 10 to 8. Okay, and this is why your satellite have delay, because satellite is normally few thousand meters or 10 of 1,000 meters out in the sky, right? Especially for the geostationary, so it's kind of provide delay. The transmission delay is when you want to to transmit on the link. So this is a bit more difficult to understand, because normally I call it Usain Bolt delay, because Usain Bolt had problem getting off of the starting block, right? So that's the Achilles heel of Usain Bolt, the owner of Olympic and world record, for 400 meters and 200 meters. So this I call Usain Bolt delay. And the rest of the delay is nodal processing. This is like CPU, RAM, and etc. Because your computer, your router or switch, in this case router is just a computer, right? So they have some delay processing the information. And obviously you have a queuing delay. Queuing delay is waiting for the queue, just like when you're waiting for the queue in the toll booth or in a restaurant queue. If you are having a takeaway during this COVID whatever situation, right? So you have a 4 delay. Just remember, this 4 delay is one is nodal, one is queuing, another one is transmission and propagation. As I mentioned, transmission delay is going to be most difficult to understand unless we have the good analogy like Usain Bolt, analogy. Maybe you bit understand, And this is a example. If you have this 10-car caravan, and you have a toll booth, and this is probably let's say within Sungai Buloh to Tapah, for example, around 100 kilometers. So you have this, car, 10-car caravan, car propagate at 100 kilometers per hour. So that's the limit, obviously, right? Toll booth take 12 seconds to service a car. Let's say, imagine this is not a smart tag. It's kind of, you have to pay using the money, for example, right? So a car is just like a bit, and caravan just like packet. How long until caravan is lined up before a second toll booth? Time to push entire caravan toll onto highway is a 12 and 10 second. Time for the last car to propagate from first to second toll booth is 100 over 100 kilometers per hour. Is about 1 hour. So it's kind of, it's normal, right? But the answer is that you have to plus 120 seconds, which is 2 minutes, with the 60 minutes, and this basically time, both time for the toll processing delay and the propagation delay between these two. So you have this about more than just over an hour or 62 minutes. That's fine. But the problem is when your car become very fast. Okay, this is happen when that the packet, data packet or the internet packet, network packet travel at the speed of light. So in this case, you have very fast car. In this case, instead of 100 kilometers, you have 1,000 kilometers. Let's say you are in Autobahn, German, you can travel, there is no speed limit, you can travel 1,000 kilometers per hour. I'm not sure I don't know, people can travel this fast. Let's say your Bugatti Veyron, whatever, right? Very fast car can travel this fast. As you can see, suppose car now propagate at 1,000 kilometers. The question that will car arrive second boot before all car service at first boot? Yes, actually the first car will arrive, after 7 minutes. First car arrive at second boot. 3 cars still, the rest 3 still in the. So this is going to be bad, because as you can see, then this is unnecessary delay. As you can see, the queuing delay here revisited. You see, this is the highway is very empty, and then you have very kind of jam-packed highway. Normally it's happened during the peak hours, or maybe if there is a thunderstorm or whatever problem in US. Normally they have this hurricane, whatever, they have to evacuate, so they have something like very traffic jam here. As you can see, as you go to if a lot of car arriving or vehicle arriving, the traffic intensity become very large, and then it's basically unusable. Unlike circuit switching, this is because the packet circuit switching, you don't have this because they are reserved, but limited number of packet or vehicle in terms of vehicle can share. But in this case, you have many vehicles, and then the delays become very large, and the delay become very large, and some of them get lost and never arrive, and then you have to send again. In the virtual, you can send again, but still it depends on the application, right? Whether you can accept or not. For video application, probably you don't need to send again, but for CV, email, whatever, you need to send again. So this is an example of real internet delay and route. If you want, you can use this trace route program, and as you can see, they send this average probe to see the average delay towards the destination, and then this end-to-end delay. You can try this inside your inside your Windows. I think the Windows, the command is tracert, TRACERT, and Linux is a trace route here. So if you trace route from US to France, as you can see here, the overall delay 136 milliseconds, which is, it's not good, but still, 50 milliseconds is good, but this is not that good, but still better, because consider this is transoceanic between America is separated by the ocean, right? You have this Atlantic Ocean, if I'm not mistaken. So this is transoceanic link. As you can see, it's about if you minus this, about tenth of a millisecond, right? So this is not the bulk of this, under 36, majority of them, more than half, actually correspond to the transoceanic link. That's why you need to have this content distribution network, like I mentioned in Google, close to your, for the video, especially close to the regional where the video going to be consumed, like in the Malay language video. All right, so a packet loss, preceding link in buffer has finite capacity, packet having full drop, lost packet may be transmitted by previous node by source. So when you have a excessive delay, you can have loss. And then throughput is basically the immediate rate between the sender and receiver. The idea is that you have to understand that even you have a large capacity here. For example, I have 300 megabit capacity for my home network supported by Unify. If my server have a lower link capacity, let's say my server that I'm accessing to have only 10 megabit per second, because it's because in internet anybody can host their own client server. Let's say the server become popular, a lot of people access, or they can afford a high bandwidth. I'm limited, even though I have a 300 megabit per second network, because the server that I'm accessing have a 10 megabit per second. So basically, my effective bandwidth is not 300 meg. My effective bandwidth is my limited, at the server, or vice versa. If the server have, let's say Google server have a large bandwidth throughput, but I don't have a large throughput, then it's going to be my bottleneck. So as you can see, if you have what is the average end-to-end throughput, the answer is going to be the bottleneck, right? The effective bandwidth is RS. It's not the combination or the average of this one. This is going to be the RS. Similarly, this one going to be the RC, not the average or the combination of this one. So this is we call it bottleneck in network. So the effective bandwidth, the smaller of the two. All right. I think this is the same one. Okay. I think before we finish, I just quickly go to this protocol layer. All right, and the idea of this protocol layering is similar to your air travel, where you have this separate layering for each function, for example, ticket, baggage, gates, runway, and plane. So yeah, you need this because it's a complex system. Network is a complex system, so you divide this. So in this TCP/IP stack, we call it, right, transmission control protocol or IP, internet protocol stack, or we just call it IP stack. So you have 5 application, transport, network, link, physical layer. So this is the function of each one depending on their context. All right, this is a 5 internet protocol layer. Application is basically your web, whatever that you use to. And transport, you can have a TCP or DP, depend on the connectivity quality or reliability. And then the network layer, basically you route the datagram and you link. This is your access layer, which is your Wi-Fi or your Ethernet. And then your physical, you have this a bit on the wire, right? We discussed a bit about physical and link and network just now, right? So the new here is application and transport. So basically they're the upper layer to manage your connection. And again, you have a 7-layer ISO reference. So basically, this is not, it's not popular model, the one that we use. This one, you can forget about this one. So how they have this encapsulation, as you can see, this animation, right? Yeah, you have this source to destination, and you have the switch and router, which is 2 core, popular or important core network component. As you see, you have a message here, and you have a header, and they kind of, transmit over the network. As you can see, they are, the message passed down by adding the header, and then they go using this, the message, the data, and then you have this header as a metadata. They describe the data, and then you can find the destination. For example, if you have a billion or million connected device, because of this metadata, you have this proper addressing, then you can achieve your destination. For example, if you go to the web server and then they arrive at this, you request a file, and then they will return back the similar way. So basically, just the process of encapsulation or packetization, if you like. All right. So if you want to learn more, you have a computer networking learning tools, GNS3, Mininet, NS3, Wireshark. This is sniffer, free, very popular one. You can even integrate this packet sniffer with your this open source free simulation. It used to be very expensive, 10,000 USD, not Malaysian ringgit, right? But now you can get it free. So you can integrate this with any of these simulator, and you can learn and explore. And then the question is that there's many of jargon or internet jargon, they call it, or terminology or acronym. But as you go by, you probably learn this as like we learn a new language. That's how we do. And then this is a future network, for research. Obviously, if you're working in networking area research, you're going to, some of my students working on this SDN and cloud computing, quality of service, network slicing, cybersecurity, enable blockchain, Bitcoin, non-fungible token. This is the latest one that people, that you can sell your digital kind of asset to other people, and you can sign it. For example, people like Tim Berners-Lee, the inventor of the web, they just sell the first code, source code for and signed by him for the first web browser. I think I'm not sure how much he sell it, but he sell it to somebody to make as a collectible, right? Call it non-fungible. And then you can connecting to the unconnected digital divide mentioned inside the My Digital initiative by the Malaysian government. We want trying to connect the remote the people in Kinabalu on in Sabah, whatever, right, in the Kinabalu mountain, whatever, right? So hopefully they can even attend the online class, for example, right, using this. Yeah, I think that's a conclusion. We finish now because the time is already over. And I hope you can appreciate and understand the principle of circuit switching, because packet switching is what we have now. Just to give you some understanding and appreciation of the current computer network. And packet switching already won, even the 5G, 3G used to be, I think, circuit switching, not packet switching. But now the 4G and 5G, they all go all out to be packet switching. IP is a de facto TCP/IP model, internet protocol, which is a network one. So now they mention about everything is over IP, IP is over everything. So kind of the common, if you want to connect to internet, you need to speak IP, or the latest one, they call it IPv6. But still, IPv6 is still not very popular because IP is still usable. And maybe sooner or later, they will move to IPv6, right? And then if not any other thing that you remember for this seminar, just remember that computer network made up of the edge network, the core network, and the SS network. And obviously the bandwidth and delay play important concern, main concern in the computer networking. And the future of network is bright. You have this Internet Internet of Things, Industry 4.0, and Society 4.0. They all use computer network and Internet to large extent. So having to learn and to master the concept and understand the concept is very important for your future career or even for your future understanding of the technology being deployed. And you can understand the advantage, the disadvantage, benefit, the limitation, and so on. And lastly, last but not least, do not be afraid to explore the wonderful world of computer networking and take up the opportunity to make history. And as I mentioned in the beginning, now you can even connect to the Mars using this robot moving on the planet Mars, which takes you several months to travel, but using internet, you can go there in a few seconds or close to real time, just by by accessing the server set up by the NASA, whatever, right? This government, U.S. government or maybe the Chinese government that already have a server on the Mars. All right, thank you very much. This is reference I mentioned to you in the 8th edition now. The one I show you here is the 7th edition. Yeah, it's a very nice book. I suggest you read this book if you want to explore. And then for IoT, I recommend these books from Cisco if you want to know the fundamental of IoT. But anyway, the first book is a must. The second book is optional if you want to learn more about the latest IoT and Industry 4.0. All right, thank you very much for your, if you have any question, I'm not sure whether we have time for questions or basically maybe purposely, exceed the time so there is no question. But anyway, Hashim, is there any question session? Because the time is...
Okay.
Yeah,
okay,
if we can take 5 minutes, I'm not sure whether...
Open.
Yeah.
Yeah, we can open the question for participant. Can ask. We are open now.
Any question, Hafiz? Daniel Hafiz, I'm sure right now TNB is working towards the smart grid, like Dr. mentioned. Our dumb meter will be replaced with meter which forming smart. We know that this smart meter will be suitable to be implemented in your opinion, this meter suitable to be implemented in a rural area where the basic communication infrastructure are missing, are not well equipped. Okay, thank you, Hafiz, for I think very good question. To be honest with you, my house and in Bandar Sri Putra, Bangi, whatever, Kajang, and my sister house in Shah Alam, Subang, they already have this meter. I think maybe your house, I'm not sure where you live, maybe they're going to have a soon. As you mentioned that the rural area is going to be a challenge. Actually, part of my research and my PhD student as well, we have a collaboration with Hitachi trying to solve this very problem. But again, as of now, if you want to solve the problem, you need to spend a lot of money, which probably not all government can afford it or company can afford it, because company is a chicken and egg problem. Company need to invest and they need to have return on investment, sooner rather than later. So who's going to do that? Fortunately, I think Malaysia, they have this initiative. They call it, I can't remember the name, but under this My Digital initiative, under Ministry of Communication and Multimedia, they already proposed, I think, 10 billion, if I'm not mistaken, 10 billion. This is 10,000 million, equivalent to, I think, in Malaysian ringgit, to kind of set up several hundred of tower, even to the remote area. I'm not sure how remote it is. Is it remote until the Mount Kinabalu? I'm not sure, or Taman Negara, but still, I think this is a welcome addition. For your information, they're going to finish upgrading the whole thing based on this 10 billion allocation by, I think, inshallah, by next year. So hopefully, most of the remote area probably can be connected, for this 10B meter or for online meeting. But still, obviously, even this 10 billion will not cover the whole country. That's why actually US actually they already spend, if I'm not mistaken, 10 billion USD. You can check, not Malaysian ringgit, to this Tesla, whatever, Elon Musk company that provide this satellite base for rural area. That will be more, I think, better in a way that because satellite you can cover greater area compared to the base station. All right, but Malaysia is going to that's going to be very, very expensive to pay this company, US company. So actually we go to the base station kind of approach similar to what we have. It's just that we have more base station installed based on this I think 10 billion allocation. According to, I think government is a private and public and private partnership. That means the money is I think from both sides of the stakeholders. Okay. I hope that's answered the question. Is it okay, Hafiz? Yeah, Azizi. Oh yeah, the service is Starlink, right? Or can we order and use Starlink service by Elon Musk in Malaysia? Yeah, obviously, if they cover the Malaysia area, then we can. The idea is that Elon Musk, they want to cover the whole world, and then the price not going to be cheap. But I think if the idea is that if the government maybe can sponsor some of it, then maybe you can. For example, probably you don't need Starlink connection. If the satellite Starlink does arrive or do arrive in Malaysia, that cover the remote place, for example, Mount Kinabalu or any Taman Negara in Pahang, for example, right? Or in Sarawak jungle, right? Borneo jungle is considered very dense kind of area even to penetrate. Then maybe government can subsidize this, or maybe maybe they have this affordable price to once. I'm not sure whether what is their plan roadmap, but you can check their roadmap when they say maybe within 10 years they're going to cover the whole world. So yeah, it's not going to be soon because they're going to prioritize the US, obviously, right? Because they just got the money from the US government, as I mentioned, about 10 billion or so USD. So that will be happening soon, maybe in the US. So yeah, the good thing is that basically you don't need, they say that you don't need to stay in San Francisco or Silicon Valley anymore. As you know, that Silicon Valley is very expensive. One house, probably, 5,000 USD, whatever, right? Now you can, even you work with Google in Silicon Valley, you can just go to Las Vegas, whatever, and live there, and and subscribe to this Starlink high bandwidth capacity. Hopefully, they got a good performance, and then regardless of where you are in US, but Malaysia maybe will take time, Azizi. I think so. Yeah. If they ever come here. All right. Any more question? Maybe 5:50 now. Any more question, or maybe
maybe can answer the Dr. Ratna asked before this.
Oh, Dr. Ratna, sorry, I missed it, Dr. Ratna.
Before rest, the maybe about cost. How much is the cost to upgrade during the around 356? Yeah.
Okay, can you say that again? Whose question is this?
How much is the cost to upgrade?
To upgrade?
Maybe the around before rest time. Dr. Ratna.
It's about the Unify. You upgrade. How much it costs?
Oh no, actually it's free, Dr. Ratna, because they actually I have a 10 meg from you're talking about my Unify, right? Okay, I have a 10 meg actually. I think it's cost the same that I will pay now. It's 180. Sorry, 140 something, 50. And then they asked me, do you want to upgrade to 30? I say, why not? I upgrade 30, and then I just pay another 20 ringgit more, so it's about 180, I suppose. And then when at one time the government say they want to increase the connection, right?
Yeah.
And they increase the connection for free from 30 to 300 meg. If you subscribe to the highest, I think at the time is 50 meg, right? I'm not sure. If you have the subscription for 50 meg, cost about 250 or 300. The max, my friend got that one, but he was working with telecom. He can afford it, maybe. So he got upgraded to 800 meg. That's automatic upgrade. So now essentially I'm paying for 30 meg, but I got 300 meg connection due to automatic upgrade. Yeah, depend on your place. Actually, if you covered by Unify, now I think the default one is 100 meg, 300 meg, and the maximum is 800 meg. I think no more upgrade now. Yeah, when you subscribe a new one, then they already give these values, right? Yeah. That's. I hope it's answered the question.
I'm paying 200 now.
Oh, you're paying 200. I'm not sure. Maybe at one time, at the moment I pay around 180. About that, yeah, 70 or 180.
And then they keep calling me, ask me whether I want to upgrade. If I want to upgrade, I have to pay another 20 ringgit per month.
Yeah. I mean, it's about. So the total you have to pay is 180 or 200. I can't remember.
Then it becomes like 220 right, if I want to upgrade.
Okay, 220 for how much they give you? I mean, the new data rate?
I'm not sure. I think it's 100 or 500. I'm not sure. I have to check.
I mean, now they give you 200. Now they have another extra 100. Okay. So actually, I'm their loyal customer lah, if you like, because as I mentioned, my hometown is Bandar Siputa, one of the earliest kind of thing, right? So I've been subscribed to them for quite some time, and then when they upgrade, I think I pay, that's why I pay 180 to 180.
Is the reception okay? Is good? Because
very good. I can recommend 300.
Because in my house is sometimes it's lag. It's like
Yeah, but it depends on the area, I suppose. But normally, if you have a fiber link,
my house is fiber link.
Okay, you have a fiber link. I think maybe you need to maybe there's some problem. You need to check with your you need to report if the quality. For me, I think most of the time the quality is very good. So I can recommend this Unify. Maybe this is on record, right? But anyway, maybe not because I have Unify Mobile as well. Maybe Unify Mobile is not very good because I'm going for their unlimited services, right, for their mobile, right? But the service is not very good, to be honest. Actually, it's already published. The service is not very good for the mobile, but the landline is very, very good. I'm quite happy now, to be honest. You never know in the near future, but now I'm quite happy with 100.
Okay. So,
I don't have money to upgrade to 800. Sorry?
But you cannot watch Euro 2020 on Unify, right?
Oh, okay. I'm use Astro.
Oh, you have Astro as well?
Yeah, Astro. Because my wife paying for it.
Saya
all right. Okay, thank you. I hope it's answering your question, right? Yeah.
Okay.
All right.